Let's start with an overall summary. We just want to know some counts. We've got two different predictor variables. They're both categorical. We've got rank, whether the soldier was a private or a higher ranked. And we've got infantry, their duty, whether they were in the infantry or whether they were in the non-infantry. And so what if we just wanted to be able to make some summary statements about how many in this group were privates, how many were higher ranked, how many were in the infantry, how many were not in the infantry. Right now it's kind of hard to see that data, so let's go ahead and rearrange it, reorganize it. We're going to create what we call a contingency table. When you're organizing your data by more than one categorical variable, you lay out the data, the levels of those variables, in a table, and that's then called a contingency table. So the levels of one variable will be listed across the top of the table, the levels of the other variable will be listed down the left-hand side of the table, and we'll call this a 2x2 table in this case, because each of our variables have two levels. So each of those number 2's refers to the number of levels in the variable. We'd write it like this. This is going to be a 2x2 contingency table. So we write it with an X, but we pronounce that letter X as the word by. So let's lay out the levels of our variable duty across the top of the table. So that was infantry, and then I'm going to type a tab, and non-infantry, and then we're going to want to total that. We want to know, we're going to total across the rows as well. We're going to lay out the levels of the other variable going down the left-hand side, and this is their rank, right? Whether they were a private or whether they were higher rank. And again, we're going to add a total. So in this cell here, in cell B10, we want to know how many in this sample were privates assigned to infantry. Do you see what that data is? All of the data that will fill these 4 cells in the table right now are sitting in these 4 cells as a single column. We're going to need to remember what our data coding was. And usually 1 means yes, 1 means positive, and 0 would mean negative. So this is written as private, so the 1s are yes, that is true, the 0s are that is not true. So these would be the privates, these would be the higher ranks. And then for the infantry, these would be the infantry, and these would be the non-infantry. So in this cell, we want privates, yes, infantry, yes. We want the data number from C2. We're going to copy it and paste it. In C10 here, we want private, yes, infantry, no. Oh, okay, that's that next number there. Higher rank and infantry. And then higher rank and non-infantry. Let's find some totals. So we're going to sum across the levels of duty in order to know what's the total number of privates in this data set. So this is going to be, so here in D10, we want to have that equal to B10 plus C10. And I can use my fill function to fill down to count how many overall were higher ranked. Let's do the same. So we're adding up, regardless of what rank, how many of these were in the infantry. And I'm going to sum it all the way over. So we now have our totals and our total sample size. And we can answer questions like, How many privates were there in all? How many infantry members were there in all? Which was bigger, the infantry or the non-infantry? This is a sample, but it was a sample taken at random, so we would expect these same proportions to hold true for the whole population. I've used that word proportions. We haven't actually calculated the proportions yet, but we wouldn't expect the raw number to be the same, but we would expect the proportion of 3,000 to 4,295 to be mirrored in the entire population. But we are going to need to calculate the proportions in order to do a little bit more work, and so our audience doesn't have to. So we're going to make another contingency table. In this contingency table, we're going to calculate the proportions represented by these raw numbers. So we want the same titles. We're going to use those data labels. So we now want to ask the question, what proportion of the total sample were privates in the infantry? So we're going to, what would the formula for that be? What proportion of the total sample are privates in the infantry? So privates in the infantry divided by the total sample. Let me show you that again. I'm typing an equals sign. I'm using my mouse to click on what will be the numerator, in this case, privates assigned to non-infantry. I'm then using my hand to type the divide sign, and then clicking on and then using my mouse to click on the denominator, the total sample. And then I'm typing an enter to accept that formula. Go ahead and fill in the rest of those. Let's do it for the totals as well. So you wanted a proportion or percent. Excel's returned this initially as a decimal. That's all right. Excel understands that decimals and percents are the same thing, just written either as a fraction of a 1 or a fraction of 100. So we're going to highlight all of those and just change the formatting. We're going to use that percent hot button to change those to percentages. It took away all the decimal places. APA style likes to have 2, so let's add back 2 decimal places. This is giving us very interesting information. This is telling us of the total, 91% were privates. Only about 9% were higher rank. Also, we can look at this and very easily see that of the total, nearly 70% were assigned to the infantry, while 30% were assigned to the non-infantry. I think this information is probably best included as a table. I don't think that a visualization is really going to add much more to our ability to interpret this. So let's go ahead and format it as a table. If you need to remind yourself about the guidelines or the details of designing a table, go ahead and take a look back at the design guidelines. Excel does have a format table hot button, but they tend to be very obnoxious. So we're going to practice just formatting this as APA style. Let's format the headers here. I'm going to go ahead and highlight those and center them. We then need to have a top and bottom border on the header row. So I'm going to highlight the whole header row. I've included that blank cell above the data labels because that's going to look nicer. My hot button for for borders is right here. I'm going to come and select bottom border. I'm going to leave them highlighted and come and select top border. And so you can see that's just added a very subtle line, top and bottom. I need a border at the very bottom of the table. So I selected the bottom row of cells and selected bottom border. We're getting very close to what APA style calls for. I'm just going to bold my data labels. And that's about it. We could adjust the spacing a little bit. Tables need titles. We always want to consider the outcome by predictor variable as the title. In this case, we've got two predictor variables, haven't we? We've got rank and duty. So the outcome, what have we calculated? We've calculated the percentage of the total sample by rank and duty. That needs to be italicized. So if I need to italicize that. Another piece of information that we need to include is the sample size, because as you see, we have lost the sample size in this by calculating them into percentages. So I think we can slip that into the title, percentage of the total sample. I'm coming up to the formula bar to do my editing here, and I've clicked into the formula bar right after the word total sample, and I'm going to say in parentheses, capital N equals, what was my sample size? 4,295. I've used the capital N because it's referring to the entire sample. We use a lowercase n if it's referring to a subset of the sample. When you're happy with your table formatting, go ahead and copy and paste it into your Word document and add a sentence or two that describes what this information gives you. What do you now know about this data? If you need a reminder about the guidelines for narrative, you're going to find those under the Design Guidelines tab.